It's Advent of Code Day 9, and the problem for today is encoding error. So we're getting back to our in-flight entertainment, which seems to be us taking a couple paper clips and MacGyvering a connection to some non-standard port. And once we do that, we are getting a stream of data from the exchange masking addition system. And what do we want to do with this data? I don't know. We want to parse through it and see if we can find, we're trying to find a weakness based on some old cipher. So what we're looking for then is a particular number in the sequence where the preceding X numbers have no combination that adds up to that number. So in our example data here, we're working with sequences of 5. So we skip past 1, 2, 3, 4, 5, because those are our initial 5. And so we say, for this value, is there some combination of two values in the preceding 5 that sum up to 40? And so you can try a bunch of combinations and you figure out that 15 and 25 sum up to 40. So this isn't our weakness. So we move to the next one. And now our window is only these 5, and 35 is out of the picture. So we say, are there any two numbers in the preceding 5 that add up to 62? And we look and we realize 47 and 15, those add up to 62. And so then we continue like that, so on and so forth, until eventually we reach 127. And we look at these preceding 5 and we realize no combination of any of those two numbers will add up to 127. So that's our weakness. And that's the answer, at least for this sample input. And then we'll get a much longer list of numbers with the puzzle input. But let's see if we can solve for the sample input first, and then move on to the full input. So I'm going to copy those numbers. And one other thing to keep in mind is, so our preamble length here is 5. So we have a sliding window of the previous 5 things. But when we get down to our puzzle input, we're going to be working with a sliding input of the previous 25 numbers. So we'll need to make that switch in our solution once we get there. So I've copied these. And now let's jump over here and we'll make our day 9 directory. And to do something a little different today, I want to see if I can solve this in SQL. See if I can solve this in Postgres, writing some SQL queries. So for starters, I'm going to create a sample.sql, and we will create a table. So we'll do create table. What do we want to call this? Xmas data, and it'll have ID, serial, primary key, because I'm thinking we're going to want to have identifiers for all the values we cram in here so that we can kind of keep track of this window as we analyze the data. And then we'll need the values themselves. So say value, integer, definitely don't want those to ever be null. So I think that's our table. And then we'll insert our data into the table. The primary keys will fill in automatically using some auto-incrementing value. So we'll just set the values themselves. And let's see, I'll paste these in. And so to work with these, I have to create a visual block selection, put the parentheses on the front, create another visual block selection, and then put the parenthesis closing on the end. And then down here, we're going to end that in a semicolon. So that'll insert our data. And just so that I can, this is sort of our input script. So just so I can make this sort of idempotent, I'm going to do a drop table if exists Xmas data. Cool. So feel good about this. Let's say open up PSQL and let's see if we can run this file. Actually, yeah, that's fine. So let's see if we can run this file. We did a drop table. We created our table. We inserted the data. We can select star from Xmas data and see that that's there. So now we need to start playing around with this. So in order to even start solving this problem, we're going to need to create some sort of concept of like summed pairs. So like I want to have the sum of like 35 and 20. I want the sum of 20 and 15. I want to have the sum of 35 and 15. I want to kind of do that for all of these so that I can have these windows of sums that I can then check against each of these values to see whether it's a weak point or not. So that to me is saying like we need to do a cross product. So I could do that by selecting star from Xmas data and then just doing comma Xmas data. And then we can't call those the same thing, so we'll have to give them different names. V1 and V2. I don't know why I'm calling V1 and V2. So this is data, I'll go D1 and D2. So with that in place, there we've got this cross product. But this isn't perfect. We've got 1 paired up with 1, and we never want to sum up values that are sort of the same position. We only want to sum up 2 different values from the preceding X number of values. So we will exclude those or filter them out using a where clause. So we say where D1 ID does not equal D2 ID. So that gets rid of those. That's great. And just to create a little more insight into where we're headed, let's say D1 dot value plus D2 dot value. Call that sum. And now we can see these sums forming. And yeah, do we ever see? Yeah, I was going to look for that 40, but I think that's going to show up further down here and I'm getting ahead of myself. Yeah, there's the 40, the 25, and the 15. But anyway, I guess I want to take this one step further. A lot of this data isn't going to be relevant. The data I've returned here, I've got 380 rows. And, oops, okay, so I've got 380 rows. But a bunch of those rows are kind of junk rows. Like we're never going to be wanting to use 20 and or not even that one. Like 19 and 11. Those aren't within a 5 number window. So that value 411 is never going to be relevant. So I want to, I guess, add an additional piece to my where clause where it's like if the D1 ID, if like the difference between the D1 ID and the D2 ID is, yeah, how would that work? If it was, right, so like 19 minus 11, if that would come out to 8, and that would be too big of a gap. So we only want ones where the gap is, I guess in this case, less than 5. And since we'll be comparing both sides of that, we'll say absolute value. And let's see, now we're down to 140 rows. So let's quite a big drop, and I think that's going to come in handy when we're working with a larger chunk of data because we've got less to process then. So this is sort of some starter data to work with. It's getting out these sums that we can use. And so I'm thinking we could use this as part of a subquery. So if we were to wrap that in there, we could say, select, we want to join this subquery against like the Christmas data itself, so that we can compare each row to, so each row of Christmas, this like top level Christmas data, we can compare that to like a bunch of values that are in its like preceding window. So we'll select star from Christmas data. And I guess we'll do a cross product here as well, at least to start. So I want Christmas data dot star, and then to work with this table, we need to give it a name. So I'm going to call it sum table, and then we need to give identifiers to the values that it returns as well. So I guess more specifically, I just want the IDs. I don't think I care about these values coming out. I just want the sum and the IDs. So I'm going to say d1.id is d1 ID, d2.id is d2 ID, and then we've got the sum. So if I run that, I think I'm just going to have a massive table, and I'm going to spit out a bunch of Christmas data. Yes. Okay. So I feel like we're on the right track here, but we're going to need to, I guess, filter out a bunch of input to move towards a solution. But I think to make this easier to think about, I'd like to focus on just one of our rows at the moment. So I guess I want to say where Christmas data.id equals 6. Yeah, so that's value 40. And we'd see there's a ton of those rows. And if we were to include the sum table as well, we'd see why we're getting so many of those rows. So now we're getting, because it's a cross product, we're just getting, this sort of explosion of rows in this table with rows in this table. So now we need to filter that down a little bit. We only want to, we only want to compare the row 6 to the preceding 5 values behind it. So when we end up comparing it to like itself here, or row 7, or you imagine if we continue to scroll down, we'd see all these values greater than 6. We're suddenly making these comparisons that aren't of interest to us. So I want to, I guess, add to this by saying where xmasdata.id minus the sum table d1 ID, I want that to be in a range of like, it needs to be somewhere between 0 and 5, I guess. Yeah, because you want it to be within 5 of it. So we would subtract that and say it's got to be less than or equal to 5, and xmasdata.id also has to be greater than well, after the subtraction, sum table dot D1 ID has to be greater than 0. And so if we do that, we're going to trim down our results a little bit here, and we're going to start only seeing D1 IDs that are behind 6 by 5. But you'll see we've still got the D2 values creeping in. So we're going to have to do sort of this same dance with the D1 ID values. But this query is getting a little hard to read, so let's open this up in the built-in editor and see if we can make things a little easier on ourselves. So I'm just going to format this a little bit. Oh, I just want to tab that. Okay. Jump to the other side of this. Oh, that's the name of our table. Okay. And then we have our where. And now we have this series of wheres, and these are going to be a lot easier to read now. Okay. Clean this up a little bit as well. Not going to do as much formatting on this subquery, but at least enough to not have us scrolling off the end of the page. Okay, so we need to do something similar to this, but we want these to be D2 IDs. Okay, so if we run that query, yeah, now we're trimming things down. And eventually we're going to see, okay, there's a sum that matches that. So our 6 value is, or the 6 position value is valid. Yeah, but where do we go from here? I mean, let's open this back up in the editor. I guess instead of, only finding value 6, I want to do it for all values except for the initial window. So this initial window of 5, we want to say, is the data ID greater than 5, then show us the data. So now we're seeing these clusters of data for the IDs that we care about. And if we edit this, we can actually add in an order by clause because it didn't like the way that was displaying. Okay, so now all the 6s are clustered together, all the 7s are clustered together. And we can kind of go through and spot check this. 62, 62, then we get to our 8s, so on and so forth. And if we go all the way down to 15, I think we'd see that, we're not going to see 127 anywhere in this list. So knowing that, how do we then sort of get the query to tell us that? If we open this back up, I guess I want to do a little bit more with what we're selecting here. We're kind of looking at a lot, so I wonder if we could group by the Christmas data IDs. And that way we can array aggregate the sum table sum. And that might make this a little nicer to look at. So yeah, now we just have one row for each of these numbers. And we can look in these arrays to see, hey, do we have the value we're looking for? And so, yeah, I think we can do like a comparison with the with like array utilities. Yeah, what is that? I think like select if you have an array of like 1, 2, 3, 4, and you have an array of 2, that would be true. If you have an array of 1, 5, that would be false. You just wanted to do like a single value, I think like that. So this little birdie beak operator is what we're looking for. So let's add that in. Just add that as another value. So we'll say the array ag sum table.sum. If that contains our Christmas data value, we'll just check whether that's there or not, and so that'll return either true or false. We'll run that. Oh, whoops, we used parentheses instead of brackets. Lovely. And trues down the board, we had false, and we see 15, 127. So that's a number we're looking for, and that lines up with here. You know, and so we could take it a step further and add a, you know, another where we say, yeah, what is it? Xmas data. Can we use an aggregator? I don't think we use an aggregator in our where, but maybe we can use it in like a having. Where this is like false, or it's not equal to true, or it's equal to false. Can we do something like that? Yeah, let's check. So, yeah, I think having is for aggregates. The row space. However, having clause allows you to filter groups of rows. Yeah, so I think that's what I want. Some amount. Having. Oh, so it just needs to come after the group by. I think maybe that was the issue. That would make sense since the having is only an issue when you're using a group by. Doesn't like how I'm specifying false. What if I just say it outright? There we go, row 15. Okay, so I think we can do the same thing for our puzzle input. So if we command, oops, don't want to print it. If we command A and copy that, now I'm going to, I guess, quit out of here so that I can create the input.sql. Actually, let me copy sample.sql to input.sql. And we'll just place all of that. That's a lot of numbers. So we'll get rid of this. Now we'll do this same dance here. So we'll drop our Christmas data, we'll repopulate it with all of this data. And then we can see if we've got a solution. So yeah, what was it? /I input.SQL integer out of range. Bummer. I guess we need a bigger SQL big int. How do we Postgres rather? Numerical types. Let's see. Yeah, big int is what I'm looking for. Okay. Wouldn't have guessed that would have been an issue, but that's okay. Let's take another look at input. Say that's big int. Let's give that another run. Okay, we created a table with 1,000 entries. And now we've got this. Oops. Well, hopefully that gives me something to edit now. Select, and so we're working with the same table. Christmas date is fine. I think we just need to update that. All of these 5s to be 25s, since we're working with a different window here. So update that. And let's give this a run and see what it can do. Ooh, that is a lot. And if we scroll up, ID 653, value, is that our answer? Let's see. All right, we solved this with SQL. That was fun. That's part 1 for day 9. Thanks for joining in, and we'll hopefully see you for part 2.